we'll be building an API with the OpenTelemetry. So you can chat.
Thank you. Hello, everyone. Thank you for coming in. Bratislava is beautiful, by the way, and I'm super excited to be here. And today we're going to talk about building an APM with open source and OpenTelemetry. So I'm Goutham. I am a product manager for the past 3 months. But before that, I've been a software engineer working on Prometheus, hosted Prometheus, Cortex, Mimir, Loki, all the observability tools. But right before I became a PM for a couple of years, I was working on the OpenTelemetry project, mainly on the Prometheus and OpenTelemetry bridge between the two projects. Cool. And for the past 3 months, I've been a PM. Honestly, I spent the 3 months figuring out what a PM does, and I still don't know. Cool. So this is the agenda. We're going to talk about OpenTelemetry. We're going to talk about APM. I'm going to do a live demo and hope nothing burns down. And I'm going to talk to you about some of the caveats if you try to do this at home, what you should be looking at. And we're going to there's a surprise news section in there, and then we're going to end with a Q&A. But before I start, how many of you already know what OpenTelemetry is and why it's so important? Okay, that's like few people. Okay, perfect. That's awesome. How many of you are developers? Okay, some of them. How many of you are on the platform teams or DevOps teams? Wow, okay, this is a good mix. Perfect. I'm in the perfect room. All right, so what is OpenTelemetry? But before I talk about OpenTelemetry, I kind of want to talk about the problem OpenTelemetry is trying to tackle, or one of the problems it's trying to tackle. So let's say your organization has no observability. It did a bunch of analysis and say, hey, this new and cool observability tool or vendor looks really promising, let's adopt it. So all the developers then go ahead and start instrumenting their services with this vendor or with this tool or with this SDK that this vendor or tool provides. It could be Prometheus, it could be InfluxDB, or it could be a vendor like New Relic or Datadog. And then suddenly you have thousands of metrics and thousands of lines of code where you're incrementing these metrics or measuring things in your code. 2 years happen, and let's say this observability vendor gets acquired by another vendor, and suddenly the prices increase 3x. Or maybe you want to move from backend 1 to the new backend, the new and shiny backend written in Rust. Just because it's written in Rust, you want to move. And suddenly you notice that you have to go and tell all the developers to re-instrument all these metrics with a new SDK. You're stuck. The developers, it is not a priority for the developers, and this becomes harder the more mature your organization is. Some of the APM vendors and APM tools, they also provide auto-instrumentation agents. You could remove one agent and drop in the new agent, but suddenly you will find that all the metric names are different. So not only do you need to learn the new UIs and new workflows, but you should also learn the new metrics and new attributes that you need to query on. So this is the kind of problem that OpenTelemetry is trying to tackle, the problem of vendor lock-in from a code perspective. So OpenTelemetry is a collection of tools, APIs, and SDKs. You can use it to instrument, generate, collect, and export OpenTelemetry data. So this is basically a very generic explanation of things. But what it does is it gives you a standard set of SDKs and auto-instrumentation agents that you drop next to your applications in your applications. And then you export one standard out. It's called the OTel protocol or OTLP. And the idea is you're able to forward this standard to any monitoring and observability vendor that you're using. And all the vendors will support this standard. So if you want to go from vendor A to vendor B, all you need to do is change a small piece of config in a central location, not in the apps. You never change anything in the apps. You just change something in the observability pipeline. We'll get into that. And suddenly all your data is going to both vendor 1 and vendor 2, and then you can train your developers into how to use the new vendor. And at a certain date, you can do a cutoff. So basically, that's what OpenTelemetry does. It is a set of standards, specifications, and conventions. It's a set of client-side SDKs and auto-instrumentation agents, and it's also a few things in the middleware category. In terms of the standards, they also kind of define the OpenTelemetry API. So basically, what function calls or how should an OpenTelemetry SDK look like. So if you're instrumenting an application in Python and then you go and try to instrument another application in Java, it will be very similar and you don't need to learn a completely new paradigm. So that's kind of the spec of how a SDK should look like. Semantic conventions kind of define what it needs to be measured and what does it need to be called. So for example, for HTTP requests, it says, okay, the metric name should be HTTP request duration. It needs to have these recommended labels and these, it needs to have these required labels and these recommended labels and these optional labels. Like it kind of defines the data structure for the most common operations. We'll talk about why that is important, and it's also the final protocol. So if you instrument your applications with the OTel SDKs, your applications will emit data in OTLP. Yes, and it's also a set of client-side libraries. So basically, the standard OTel SDK API that has been specified is being implemented in more than 10 languages. All the popular languages that you're building your apps with will have a OTel SDK that you can then use to instrument your applications, collect logs, metrics, traces, and for some of the applications in, for example, Python, Node.js, Java, .NET, there's also auto-instrumentation agents that you can just drop beside your application. You don't need to change any business logic, and you get all the good observability data out. Even for Golang, there is some cool new stuff happening in the eBPF space around auto-instrumentation in OpenTelemetry. Cool. Finally, we kind of come to the middleware. So I said if you instrument your applications with OTel SDKs, they will emit OTLP. But maybe your vendor or backend doesn't support OTLP, and that's where the collector comes in. The collector is the observability pipeline. All your applications send data to a central collector cluster that your platform team or DevOps team manages. And then you can kind of aggregate data, add new attributes, remove attributes, like sanitize it, use it as a pipeline and route the data to where it needs to go. And because it's in a central place, you don't need to change anything in your applications. You just need to change the config of this collector. Yeah. We also have the OpenTelemetry operator. For those who are using Kubernetes, you can basically enable the operator. It deploys a collector, manages the collector, and also if it detects that you're running Java applications, it auto adds the Java auto instrumentation next to those Java agents, so you don't need to kind of even mess with the manifests. So yeah, so this is kind of typically how the OTel pipeline will look like. Your applications will write to a central collector that will send it to a vendor. If you want to try a new vendor, you just say, hey, collector, forward it to both. You can evaluate vendors, multiple different vendors this way, and at some point, if you really like the new vendor, you can just turn off the config in the old vendor, and boom. There is still vendor lock-in in that, maybe all your alerts live in this vendor and they need to be converted to the new vendor, but it's a lot less lock-in than before. Yeah. So there's a bunch of, this is a popular XKCD whenever somebody tries to come up with a new standard. Why is OpenTelemetry different from all the other efforts that came before it? I would say it's because the whole industry is kind of backing it. It's part of the CNCF, and all the major observability vendors are all in on OpenTelemetry. And it's very clear if you look at kind of the activity graph for OpenTelemetry. So this is basically on the x-axis, you have the number of commits. On the y-axis, you have number of PRs and issues. And the most active project in the CNCF is Kubernetes. The second most active project is OpenTelemetry. You can kind of see that there's been, I don't know, 20,000 commits in the last year. This is basically the whole community, end users, and vendors all starting to develop all these SDKs in different programming languages, auto-instrumentation agents, specifications, all of this. And yeah, like if you take Neuralink, Datadog, Dynatrace, any of the popular major vendors, all of them have excellent support for OpenTelemetry. So you don't kind of even need a collector. You can just directly send OTLP to a vendor and it'll work. Cool. So that's basically what OpenTelemetry is and why it's important. Let me check time. Okay, cool. So what is an APM? So if I go to 5 different vendors, 5 different people define it as 5 different things. So I decided to go to the best source on the internet, which is Wikipedia. And it defines it as monitoring and management of the performance and availability of software applications. It's kind of so generic and so vague. You pick any observability tool or vendor and they do APM, including PagerDuty. So yeah, for my talk, for building an APM, I'm going to define it my way because, I'm giving the talk. And for this talk, I'm going to talk about the definition of an APM is basically something that lets you easily instrument your applications. It probably has like an auto-instrumentation agent, and it exports high-quality telemetry, dashboards, and alerts out. The really hard part about building an open source APM before OpenTelemetry was the auto-instrumentation agents. You had a lot of different backends that kind of let you collect the data and analyze the data, but the agent part was really missing. And most of the major vendors, they put a lot of effort into it, and hence the agents were closed source. You couldn't just take an agent and then say, oh, send it to Prometheus. That's changing with OpenTelemetry. Vendors are donating their own agents into open source, into OpenTelemetry. Thereby, you get the Java auto instrumentation is already kind of production ready and being used in production, for example, and things like that. Cool. So I'm going to walk you through the demo. So first, what is the demo? Okay, I'm going to try to make this bigger. Let me know if it's big enough. Yeah. Cool. So it's like a web shop, and it has a bunch of different services like cart service, currency service, feature flag service, checkout service, product. So this is like typical over-engineering that happens in a startup. Instead of building something and getting it into market, you build 10 different things and try to get one thing to market. Anyways, there's even there's a recommendation service already for no reason. But also, if you notice, they're in 5 different languages or 6 different languages. Okay, this is not like a startup. This is just over-engineering. And this is kind of how it looks. So they're selling telescopes. And let's go shopping. And I am an impulsive buyer, and my impulse is to buy the most expensive things. So this looks expensive, so I'm going to add this to cart. Okay, no, this is cheap. Never add that to cart. Hot products. No, I want all products. Okay, there's one product. Oh yeah, there's 3,600. I really want to buy this for no reason at all. And then I place the order, and then it goes back. Yeah, so anyways, I don't generate a lot of load on this, so there's a load generator generating all this load, and all of this is open source, and it's kind of used to showcase what does it take to instrument an application. It has live examples. Java uses the Java auto instrumentation, also augmented with the manual instrumentation. And I'm sending this data from the OTel collector to Jaeger, Loki, and Prometheus. I tried to use non-Grafana products, but there is no good open source logging solution out there. So I used Loki, but you can use any of the backends and any of the vendors for this. And I kind of built some Grafana dashboards out of this. No, not this one. Okay, so first you can kind of see the service map around this. Again, typical over-engineering. Why do you need this? For no reason at all. So there's the load generator that is writing. Okay, I'm going to try to make it bigger, yeah. to the front end, which is calling the cart service, which is calling the checkout service, which is calling fraud detection service, and all kinds of crap. Yeah, so this is the service graph for this. If you want to visualize this, I'm going to try to go to the service. Okay, now let me look at the dashboards. Look at the service list. So you can kind of see the list of services that are running, all the different services, the different languages that it's in. People are still writing PHP. I don't know what people are writing it in Erlang, for example. I'm curious what Erlang is. So the feature flag service is in Erlang. So there's feature flags as well for this. Anyways, so I'm going to try and pick the checkout service. Okay, this is last 6 hours. I haven't been running this demo for 6 hours, so let's do 15 minutes. You can kind of see that this is all metrics. It also has a bunch of logs. And in the form of, there's also traces in the form of exemplars, and you can kind of jump from the metrics to traces, all from Prometheus to Jaeger. What else? You can see the downstream services that the checkout service is calling. It's calling a bunch of services, and you can see the front end is calling the checkout service. Let's see if it has any errors. It has product catalog service and checkout service. These two have errors. Let me see if any downstream services are causing these errors, or if these errors are inherent to the checkout service itself. I can see the product catalog service is causing errors. Do I want to debug what the error is? Let me try to do that. Let me do product catalog service, error equals true. Yeah, I see a bunch of traces. Let me try to pick this one. Gonna be like, I don't want to see this. Nope, nope, there you go, close. I see this is the error. Let me see if there's any logs here. Okay, so basically, there's a feature flag enabled that says, please fail this call, and that is why this is failing. So this is how you can kind of debug errors and issues. Yeah. Oh yeah, I also want to kind of show you, like, you can also jump from logs to traces. Let's just do that. You can say, I don't know, show me the ad service. And you can be like, okay, this is an interesting log. Let me try to find the trace for it. And you can jump from logs to traces as well. Yeah, so that's the kind of OpenTelemetry demo. I will talk about some of the caveats of OpenTelemetry and then jump into some of the goodness of OpenTelemetry. Yeah, cool. So the caveats. So OpenTelemetry is still very early. It has been formed through a merger of OpenCensus and OpenTracing. So it has a really, really stable and production-ready tracing APIs and tracing SDKs that you can use. But the metrics SDKs is getting there. The spec is stable, and then now people are implementing this spec. Not all SDKs do good metrics. So this demo, instead of relying on HTTP metrics, generated metrics from the traces, because the traces are so good. The semantic conventions are not very stable, so you could build your automation on top of the existing semantic conventions, bump the version just to see all the metric names changed. However, there is an effort that is happening right now on stabilizing the semantic conventions. The runtime metrics, they're coming. Logging is still pretty early. There's only 2 services that were logging. I'm just showing those logs for all the services because it's a demo. I get to do whatever I want. But yeah, in the future, logs should also automatically flow through OTel. It's a big project. There's a lot of special interest groups, and if you like a particular language, or you want to improve the logging situation in Java, you can just get involved. It's a very open community, very big community, and the vision is great on how it will remove vendor lock-in. If you want to play with the same demo that I had, you can use the APM with OTel demo. It just is the OTel demo with some better dashboards. I will open source these. I mean, I'll upstream these dashboards as well, so you can get rid of this repo. So I want to talk a little bit about why OpenTelemetry is really cool. So at Grafana, we had a lot of success rolling out SRE initiatives because of standardizations. For example, we measure most of the things that we measure are RPC services, and we have a methodology called the RED method: request, errors, duration. So whenever there's a complex distributed system and your user says, I'm seeing 500s, you want to know which service is causing these 500s. If there's a chain of services, and if the second service is causing 500s, you will see that the topmost service is also throwing 500s because it's just proxying the error message through. And it becomes hard, and that's where the RED method, the RED dashboard shines. So this is kind of a typical RED dashboard. Requests and errors are shown on this QPS panel. Latency is shown here. And here in this case, let's say the critical path is gateway to distributor to ingester. And your users see 500 errors on the gateway, you get paged, and you can take a look and see, okay, the distributor has 500 errors, so the gateway is not the culprit. The ingester has 500 errors, so the distributor is also not the culprit. Maybe I should go look at the logs of the ingester. So this is how most of our services have their dashboards, the RED dashboards. And because we use the same library across to build all our services, the metrics exposed are same. So we can then template out these dashboards and roll these across all the services at Grafana. So you could be on team A and then you move to team B. You can look at the first dashboard that team looks at because they look at a RED dashboard and you know what a RED dashboard is. And we had a lot of success through this. How many of you tried implementing SLOs at your organization or had some experience with SLOs? So SLOs are kind of difficult to adopt. So what we did is we made them extremely simple and we incentivized things. So we built a library. I mean, we built like a JSONet library. It's kind of scary, but that's what Grafana uses. It looks very complicated, but for a team to add an SLO to our SLO platform, they need to send just this config as a PR. It has the name, it has the alert name, it has the successful request expression, total request expression, and a threshold. They just send this, and we automate the generation of the alerts. We help them find out, okay, in the past, would you have burnt your SLO, the burn dashboards and all of that. And we also generate this report every week that's sent to the entire company. And I know the CEO looks at it because one time the report failed, we got an email saying, hey, I love to start my day looking at this report. It's not there anymore. So this is the company-wide SLO performance. And you can kind of see, it's very easy, it's very high vis. So the managers they want their services to be listed here. And we made it very easy. Not everything is green, We are also software engineers, we're not AI robots. So, sometimes our services fail a little bit. So the reason we could do this is, again, because the metric name and the metric structure is standardized. If you know that every single application in your organization generates the same or similar set of metrics, you can build awesome automations and roll out SRE and best practices without developers even knowing. And that's what OpenTelemetry does. It has semantic conventions. It defines what the metric name should be. It defines what labels it should have. It defines what buckets the histogram should have. It's kind of rigid, but if more and more people are adopting OpenTelemetry, you know exactly what metrics will be there, and then you can build SLOs, you can build dashboards, you can build all kinds of cool optimization and analysis on top. So that's one of the reasons to adopt OpenTelemetry. Cool. I'm kind of done with my talk, and I still have 10 minutes, so do you have any questions?
Any questions in the audience? So
right, that means
there are two questions in the Slido.
Okay, let's go for it.
So can you compare OTel versus Prometheus metrics?
That's a good question. So OTel metrics and Prometheus metrics are compatible with each other. Prometheus uses mostly a pull format, while OTel uses a push format. So you can convert Prometheus metrics to OTel metrics and OTel metrics to Prometheus metrics, and the spec is really defined. So pick whichever is more useful for you. If you want a library that does logging and tracing and metrics, go for OTel. It's a significantly more complicated SDK to work with. While you can use the Prometheus libraries, they're much simpler, but they just do metrics. However, because of the tight integration between the two, you can instrument your applications with Prometheus libraries and emit OTel. We're working on this in the future. We're working on this currently. And if you instrument your applications with OTel, you can expose Prometheus already. It works. And if you already have applications in Prometheus, you don't need to change them. You can say, hey, collector, go scrape these Prometheus endpoints, and that will convert it internally to OTLP and send it to whatever. So as to comparison, pick whichever works better for you, but they're both interchangeable and convertible. So that's quite good, at least for the ecosystem.
So there is a second question, but I think that it was already answered. Does OTel use push or pull model for communication with backend?
OTel uses push, but if you can instrument with OTel and expose a Prometheus endpoint, it comes default with the SDKs already, so it also does pull, but with the Prometheus format. Cool.
So there is.
One question.
Yep.
If I can speak.
Okay.
One question. When I read documentation for logging, this OpenTelemetry has a very weird severities. They have 20 levels. There's maybe 5 types of the errors, which some was less important, very important, and I don't know. It is some like you need a little change mindset if you won't start using OpenTelemetry.
Yes. Yeah, okay. The question is, if you look at the logging spec, you will see that there's a severity level, which is as a field, but the number of severity levels is 20 plus or 20 something, which is bonkers. You would be like, what? And trust me, I had the same reaction. But again, OTel is trying to be like a generic standard that satisfies most of the use cases. And some use cases require 20 levels. I don't know which ones. I hope I never come across those use cases, but I need like 3 levels or 4 levels, right? So just use 3 or 4 levels. I think they also have guidance saying, okay, this is critical, this is warning, this is error, just use those. You don't need to use all 20 unless you hit those weird use case where you need 20. Yeah. Again, this is the pitfalls of trying to build a spec that works for most people and most backends. Yeah.
That brings me to this question, more personal question. What's your feelings about not OpenTelemetry now, but the journey of the OpenTelemetry? But because, as I remember, it's quite a long journey and not easy journey. To be honest, I stopped watching OpenTelemetry 2 years ago because I thought that it will be never done. What's your personal feelings about this journey?
I mean, yeah, so the question is, so OpenTelemetry is, okay, it has been going through a journey, and there's a lot of discussions whenever you need to decide something, and that sounds like slow development process. I'm paraphrasing you. Would it be ever ready? That's a good question. Again, the pitfalls of trying to work with everybody and all the popular backends. Whenever you try to add a feature or remove a feature, 20 vendors will come and say, this feature doesn't work for me. So you need to kind of make sure and build consensus with all these 20 people and make sure you come up with a solution that works for most use cases, for most of these backends. And that's a slow process. However, the fruit at the end of the process is you can move from backend A to backend B to backend C without losing feature parity. Yeah, I mean, I think that's the trade-off that they're trying to make. They know that, okay, if we only support 3 backends, we can be done in 3 months. But no, they're trying to support 30 backends because the impact at the end is much higher. And I agree, it's a slow process, but the specs are mostly stable now. And now comes the implementation part. So I think the arguing and long GitHub threads are mostly done from a spec perspective. So just now that you know what the spec is, let's just go and implement it. Things will come up. There'll be an OpenTelemetry 1.1. There'll be discussions even more, but I think they're getting there.
Follow-up question.
Yeah, I mean, I completely agree with you. As an observability vendor, we commonly see people say you're expensive, and I'm like, we're open source. What do you mean you're expensive? But yes, it's basically more of a value to money trade-off, and most observability vendors have cost optimization levers that you can pull nowadays. But I agree, sometimes it might feel like there's too much data but not enough value, and I think every observability vendor is aware of it, and there are vendors that kind of prioritize, that have really good solutions for cost optimization and cost control nowadays. Yeah.
Any other question? So it seems not. So thank you.
Thank you.